Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, Panama-Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Chuck. Our phone tutors are here until 5:30 for your calls. Give us a call here in Bakersfield at 636-4357. San Luis Obispo and the outlying areas, you can call toll free at 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show live online at dothemathonline.net. And you can look for us on social media now at Facebook and Instagram, Twitter, YouTube, and Skype now.
So that's another way for you to get a hold of Do the Math. And
Yes.
Certainly a lot of things going on.
Yes.
And I was going to bring something up, and then for some reason you brought up the Skype thing and it threw me off track. So anyway, let's just continue with the program. We have a lot going on, so let's first take a look at today's Math in the News. All right, today's Math in the News has to do with baseball. Baseball season is now officially over for the rest of the baseball fans.
Yeah, that's sad.
Baseball was over probably about a month ago during the AL wildcard game, and for some others it was continuing on. So last night you and I, we settled up on the World Series and stuff, and so everything is now finished.
Yes.
So we now look forward to next season.
Yes.
Which is why I bring up the Major League Baseball logo. Do you know who that is modeled after?
I used to know. And
Do you know the basketball one?
Michael Jordan's the basketball.
Well, that's modeled after Jerry West from the Lakers.
Oh.
So this one is an old Minnesota Twin, Harmon Killebrew.
Harmon Killebrew.
So that's
home run slugger.
right.
Yes.
So that's who they say ideally who this is modeled after. But anyway, let's go on with what we're doing here. So the end of baseball season, so the new season, the schedule is already out. Opening day of 2016 will be April 4th, 2016. That is also Square Root Day. All right, because you take the fourth day of the fourth month, 4 squared, you get 16, 2016. The last time Square Root Day occurred during the season was September 9th, 9 squared, 81, 1981.
Nice.
So it was just something, kind of cool. We could build some math into the beginning of baseball season next year. So now let's dig a little deeper into this. Square root is a number of a number, n, is a number that gives n for the answer when it is squared.
Right.
So that is square root of n is the non-negative number for which square root of n squared is equal to n.
Correct.
So here are some examples. Square root of 49, 7. 7 times 7, 49. Negative square root of 64 is negative 8. And we'll see how this is a little bit different in a moment here.
Yes.
Square root of 121 is 11. Square root of 1, 1.
1.
Square root of negative 9.
Right.
Now, you want to explain a little bit about this one, why there is none.
There is no real number that
Right.
you can square to get negative 9. So for most people, there is no square root of negative 9.
And we're just going to leave it at
That's
that for
right.
right now. Just be like the other day when we had something come up, we could just do the entire program on that. But
right.
for now, we're just going to leave it there.
That's right.
And I figured we'd throw in a nice big one there, 888, square it, you're going to get 788,544.
Didn't know that one.
So that's why I had to throw that one in there, just something a little different. And that is today's Math in the News, having to do with the opening day of baseball schedule next year. 636-4357 is the phone number. We do have phone tuners available until 5:30. Before we go to our first phone call, we're going to take a look at this cartoon, and you'll see how this all ties in just a moment. So the cartoon, here it is. Lady at a keyboard, at a computer. On the newspaper, it says, hackers steal 1.2 billion passwords. Okay, what new password can I create so hackers won't steal my stuff? So her new password is, I have no $3 signs, okay? So that's her new password. And we'll see how this all ties in just a few moments. Right now, we'll go to the phones, and Dovia from Lakeside Middle School. How are you today?
Good.
And what grade are you in, Dovia?
6.
All right, as soon as you're ready, let's hear the math problem that you're working on.
All right. I'm ready.
All right, so what's the problem, Dovia?
It was 0.458 and 25 and 20, so I think it was, wait, let me see. Okay, so it was 0.458 and 38%, and I have to list them from least to greatest.
Okay, so let me make sure I have the three numbers. 0.4 was one number.
Yeah.
5/8, 5 over 8,
Yeah,
and 30%.
yeah.
I think that's 38%.
Wait, 38%.
Yeah.
Oh, 38%. Okay, I'll just
Yeah.
make that into an 8. How's that? Okay. All right, so the question is, if we're going to compare them, which form do you want these numbers to be in? Do we want them to be all decimals, all fractions, or all percents? Which one do you think would be easier?
Decimals.
Let's change them all to decimals, okay? So 0.4, we're already there, aren't we? Let me get this
Yeah.
back up here. So we have to be able to change 5/8 to a decimal, and we have to change 38% to a decimal. So let's write the decimal down here. We've already got 0.4.
Yeah.
What's 5/8 as a decimal? How do we change that to decimal form?
Would you do 8 into 5?
Yes, because this 5...
to divide it?
Yeah, because that fraction bar means division, doesn't it?
Yeah.
We're going to divide 8 into 5. So let's divide 8 into 5, right? 5 divided by 8.
And we make 550 by adding our decimal 0.
Yeah, because 8 doesn't go into 5, we have to change to a decimal. So we're going to add as many zeros as it takes to work it out, right?
Yeah.
So we don't have to move our decimals because we're dividing by a whole number. So let's bring that decimal point straight up so we don't have to worry about it. And 8 goes into 50 how many times?
Not 7. So it would be 48 times?
So
6 times.
48, that's going to be 6, right? So you
Yeah.
know that 6 times 8 is 48. So that was our multiplication facts to help us do this long division. And
Yeah.
if we subtract, let's see how close we came. Pretty close, but not a 0, is it? So it's not a 0, so we're not done, are we?
Yeah.
We're going to add as many zeros as we need for this
So
thing
do
to
we make
either...
another 0 and make it 20?
We keep working it until it either ends or we see that it's going to repeat, right? Sometimes it just
Yeah.
goes on forever, doesn't it? So we add a 0 and we keep doing it until we get tired of doing it or it stops, right?
Yeah.
So we bring down the 8 goes into 20 how many times?
Twice.
Twice, because we know that 2 times 8 is
16.
16, and we still get a remainder that's not 0.
So it would be 40.
Add another 0 and we get 40. 8 goes into
And then
40
5.
5 times, and now we know that that's going to work out even, isn't it? And we get a remainder down there.
So it's going to be 65.
0.625. 0.625 is our decimal, isn't it? All right? So let's go ahead and put that, down here. And let's put our 0.625 that we just worked out. We
Wait,
said,
it's 675?
no, we said
625.
it was 0.625 was what we just had with our long division, okay?
Okay.
You got that?
Yeah.
Right? Now let's do 38%. How do you change 38% to a decimal?
You have 100, and then you, that means you would just you add a decimal behind the 8 and take it over twice.
Yeah, so one way of doing it is just change it directly to a decimal. You said it's 38, the whole number 38 point percent, And to change it to a percent, you just move the decimal how many places?
Twice.
Twice. 1, 2. So this is going to be 0.38 or 0.38. You said 100, so you could have done it this way also. You could have said 38% is 38 out of 100, isn't it?
Yeah.
And 38 hundredths is 10 hundredths, 2 decimal places. So either way, you're going to change that percent into a decimal, aren't you? All right, so
Yeah.
we've got 3 decimals now, don't we? 0.4, 0.625, and 0.38. Now, to be careful, what we would like to do is, so we're comparing the same numbers every time, right? Let's
Yeah.
make sure that we have the same number of decimal places in each number, okay? We've got 3 decimal places in 0.625. So
Yeah.
can we make this 0.4 have 3 decimal places also?
Yeah.
And the only way we can do that without changing the value is, what are we going to add? What are we going to put on this number?
A 0.
Yeah, we're going to put zeros. 1 0, 0.40 is the same as 0.4, isn't it?
Yeah.
0.400, 0.40 is still the same as 0.4. We haven't changed the value at all, have we? We just changed the way it looks, and we've given it 3 decimal places.
Yeah.
And then we can do the same thing with 0.38, and here we only have to add
1 0.
1 0. So now we're going to compare 3 3-digit numbers, right? We're going to compare 400, 625, and 380, because this is actually 400 thousandths, isn't it?
Yeah.
And this is 625 thousandths, right? 10 hundred thousandths. And this is 380 thousandths. But now all we have to do is compare those 3 numbers. And what order did you need them in? Smallest to largest?
Yeah.
So it's pretty easy, isn't it? What's the smallest 3-digit number up here?
The 380,000.
0.380 or 380 thousandths, and I'll put the 0 there.
Yeah.
And the next one is?
400,000. 0.400,000.
And the last one, the biggest one, is this. So if I was going to put them in order using the decimals, that would be my answer.
Yeah.
But if we were going to put them in order the way they were given to us, right? Which
Yeah.
would be the first number down here?
Yes.
Which one would be the first number?
It would be the 400. 40.
So, well,
The
here's the way, notice the form they were given in, right? Decimal, fraction, and percent. So let's write our answer down here as decimals, fractions, or percents. So this 380 thousandths was actually 38%, wasn't it?
Yeah.
So if I write my answer in the same form it was given, I'm going to put the 38% first. I'm going to put the 0.4 second, and I'm going to put the 5/8
8 last.
third, right? So I can compare them using all decimals, but I'll write it in the same form that the problem was given. All right? Great problem. Thanks for calling.
Right, indeed it was a nice problem. Dovia, you still online with us? Perhaps we lost Dovia, but anyway, it was such a great problem, we're going to award a meal at Johnny Rockets. So nice problem right there. In celebration of the day after National Sandwich Day yesterday. So anyway, 636-4357 is the phone number. We do have phone tutors available until 5:30. In studio with us right now, Dr. Melissa Danforth. How are you today?
I'm doing fine. How are you?
Good. We've had Dr. Mitchell on the program. We've had Dr. Lefevre, Ron Hughes. So a lot of people from CSUB coming out sharing a lot of their knowledge with us. And we certainly do appreciate you taking out some time to come visit us today.
Yes.
The cartoon that I had put up there before, have you ever seen anything like that, you guys?
There's quite a few cartoons along that same vein.
Yeah, there are indeed. Why don't you let everybody know what you do at CSUB, your title?
So I'm an associate professor of computer science, and I'm also my department's computer engineering and electrical engineering as well, and I am the department chair as well for that department.
Okay,
So,
and there are a lot of things that you do other than just those classes out at CSUB.
Yes.
The reason I was interested and wanted you to come on the program is because part of Revs Up that you guys do with Chevron the last couple of years. We'll talk a little bit about that later on and some of the opportunities for students that are young right now, because to tell you the truth, if I was a younger man and I was not in a profession yet, I would seek you out and go with your guidance into the avenues that you have, because it's limitless
Yes.
what you have available through CSUB and
Yes.
wherever else you may go. But what I wanted to do is talk a little bit about passwords and things like that.
Yes.
So you want to show us a little something that you brought to prepare, because a lot of students, and even adults, when they go, oh, we need to make a password, they're pretty simple.
Yes.
And what are some of the ones that people most often do? How do they usually set up a
There's
password?
actually a set of common words that people will use. So for example, let me in is a very common password that people use.
Oh, really?
And there's all these lists online you can find of common phrases and words that people will
Well, somebody would
do.
think, all right, if there's a list online, I probably don't want to use anything from that
Yes.
list, but
So another common technique people will do is to take a word or phrase that has some sort of relevance to them, and they'll use that as their password, or maybe a name with a date at the end.
okay.
But what I usually point out to people is, how often do you start your password with a number or a symbol, or even just something that's a little bit out of the realm of normal? Most people start their passwords with a letter or a name. If they have a number in there, it's at the end, or
Right.
they've done the leet speak, substitute an E with a 3 or
Okay,
an O
right,
with a 0.
and we've seen a lot of that.
All of these things are patterns that attackers can detect and that they can code into their code to try to break your passwords.
Gotcha.
So typically we try to protect passwords. We put them through something called a one-way function, which a one-way function means you can go from the password to a protected password very easily. But with the protected password, you can't go back to the password easily.
Okay.
So what the attackers do is they get these protected passwords, which we call hashes, and they try to figure out what the original password was just by generating a bunch of guesses. So if your password is simple, it takes fewer guesses for
They
them
can
to
get it
find
a
a
lot
match.
quicker. Well,
So,
let's go ahead and take
yeah.
a look at some of the math behind this.
Yeah, so if we think about how a password works, you've got certain spots. So let's say a 6-character password. There's 6 characters in it. And each one of these spaces can have a character, A through Z.
Okay.
So how many letters are there, A through Z?
So we've got 26 options.
Yeah, so each one of these spaces can have 26 options. So if we look at the combination, this is 26 times 26 times 26 times 26, which is 26 to the 6 possible combinations. Sounds like a lot. That's approximately 309 million combinations, which seems like a lot of combinations.
Right, somebody would think, all right, if I've got that, I've
Yeah.
got no problem with my password because I can,
Yeah.
but in reality,
Reality is that even the weakest attackers can guess 1,000,000 per second.
okay.
Really?
Maybe say that again for, I know some
Yeah.
of the students possibly didn't hear that or understand.
Even some of the weakest attackers. So for example, we have a little, I think it's about $600 GPU rig on campus that can crack at about 5 million per second. And this is a very cheap machine that can do this. So to guess at 1,000,000 passwords per second is very easy. The common rate right now is somewhere closer to 10 to 25 billion guesses per second.
Oh, lovely.
So if we have 309 million possible passwords and they can guess at 1,000,000 per second, well then, it's very simple math here. That means in 309 seconds, they could look at all possible 6-character passwords and find the match, which is approximately 5 minutes.
So what should somebody do? So what are some,
So some of the techniques, so as we can see here, there's,
Yeah,
Yeah. So we can see that there's 2 factors that affect the password strength. One is how many options are there per slot. So how many characters are you choosing from? And the second one is the length, the number of characters in your password.
okay. Well, just thinking, I mean, so a student might be like, okay, well, I can choose from A to Z, well, I could do lowercase and uppercase.
Yeah, so the
So
more,
you could make it 52,
yes, which would then increase the complexity.
but you're still not looking at something that's very safe
Yeah.
because you just have a number of certain number of letters that you
Yes.
have options of.
Yeah, so increasing the number of characters that you choose from, which is why putting in numbers at places other than the end or symbols are very important to incorporate in there.
Okay.
And to increase the length, and pretty much anything that's less than about 8 to 10 characters now is going to be fairly easy for attackers to do this attack, which is
And
called.
I think most people, when they log into something, have passwords that are probably about 8
Yeah.
to 10.
Yes.
So you're looking to expand that.
Yeah, so
If
what
you-
I personally do is 16 characters for anything that I have to use constantly.
Okay.
So like my computer at work, it's 16 characters.
Now, my next question is, come on over because
Yeah.
we're getting ready to take another call. 16 characters, I mean, you need to have this someplace
Yes.
because you're obviously not using the same one for all
Yes.
of your different applications.
Yes, so that's the other technique I use is there's many programs out there that are called password lockers where you can create one really strong password, and that's the password you have
To
to
get you to
remember.
that.
And then you go in, you put that password into the program and you store all your other passwords in there, so you just copy and paste from the locker to the website or from the locker to your phone or
Right.
things like that, so that it makes it much easier. You just have to remember one strong password. The program remembers everything else for you, and then it's a program. It can remember 500 characters if you wanted it to. You can make as big of a password as you want to
Right.
for the program to store.
As long as you can get in.
Yes.
All right. Well, you know what? I want to talk about some of the other things in just a few moments. Right now, Chanel, a student from Sing Lum, how are you today? Hello, Chanel. Hello. Are you there, Chanel? Well, it seems as though we possibly may have lost Chanel for just a moment. So while we're waiting for Chanel to get back on, quickly, tell us a little bit about the project you do with Revs Up with the high school students
Yes.
at CSUB.
So my Revs Up group at CSUB, they come out for 4 weeks during the summer and they work on cybersecurity projects. So the more popular one is this password project where they get to play around with that little, very small but still powerful machine
Okay.
to learn how to crack passwords so that they can learn how to make stronger passwords by seeing what makes passwords weak. We've also had groups do digital forensics where they look through a computer system for evidence that's hiding in files or evidence that's hiding on the disk drive. So that's another group we've done. Social engineering we did in the past where they learn about the social attacks that the attackers make, so tricking people, conning people into giving up information.
Okay.
And we've also talked about network attacks. So those are all different activities that they can come out for 4 weeks and learn about in the summer at CSUB.
And I mean, that whole Revs Up program is fascinating. I've had an opportunity to work a couple of years with that, and it's fun to go around and see the different projects
Yes.
that the students are working on. Right now, I think we have a Skype call right now, and is it Elizabeth possibly?
Oh, okay. You're going.
Elizabeth
Hi.
right there? How are you today?
Good.
What grade are you in?
4th.
At what school?
Jefferson.
All right, as soon as you're ready, let's hear that math problem you're working on.
Read your math problem to them.
Marissa is doing the laundry. She folds 16 items of clothing for each member of the family.
Sorry, I think we,
Yeah, it's breaking up a little bit. I've got the problem right here. So Elizabeth, listen to this and make sure this is the
Okay.
problem you're working on. Marissa is doing laundry. Irrelevant, really, when we take a look at what we need to do
laundry,
here anyway.
okay.
She folds 16 items of clothing for every member of her family.
For each member, okay.
There are 6 people in Marissa's family. How many items of clothing does she fold?
6, did you say 6 members?
Yes.
Okay, 6 members in the family. All right, so Elizabeth, you've got 16 items for each family member, correct?
Yeah.
And you've got 6 members in the family. That's family right there. And I crossed my L. I guess I could get rid of that.
I thought you were in fraternity or something there
Yeah,
for
I
a
know.
second, but it's
All right, so how could we count how many pieces of laundry were folded? Do you have an idea of how we would count how many items of laundry?
No.
Okay, so one way we could do it is we could take one family member is going to be 16 items, right? And another family member would be another 16 items, wouldn't it? For
Yeah.
each family member, we're going to have 16 items, and we're going to have 6 members. So I'm going to have 16, 16, 16, that's 3, 4, 5, 6. So one way I can do this problem is just to add up 16 6 times, couldn't I?
Yeah.
But instead of adding it up, we could take 16 6 times, couldn't we? We
Yeah.
could take 16 times 6 to get the same answer. So which way would you like to do the problem? Would you want to do it by a long addition problem or one multiplication problem?
One multiplication
So
problem.
let's go ahead and do the multiplication, right? 6 times 16, what are we going to get when we do that for 16 items and 6 family members? 6 times 6? So what do we get? 6 times 6, that's 36, right?
Yeah.
And then 6 times 1 is 6 plus 3 is 96.
9.
So if we multiply those two numbers together, 16 items per family member times 6 family members, we should get 96. And if we do it over here, if I can get this to move up.
See, it's doing that because it doesn't want you to add them.
Yes,
it
I
knows to
guess
do it the
not.
easier way by
If I
multiplying.
add all of those 16s together, I should get 96, which is the same answer that we got when we multiplied. Okay?
Nicely done. Great problem right
Thanks
there,
for the call.
Elizabeth. And thanks for Skyping with Do the Math. We do have phone tutors available until 5:30. Dr. Danforth, when you first came on, I said, you know, if I was a younger man, there were some opportunities in this field. So talk a little bit about the opportunities that are there for students that are at CSUB, possibly going to CSUB soon in a couple of years, what they can expect if they go into this field.
So in cybersecurity right now at CSUB, we've got a concentration under computer science. So they'll do a lot of computing classes, but they'll also do electives in cybersecurity. And their diploma will actually say computer science-information security as their major to display proudly on their wall when they complete. And so the idea with that is that we want students to have that foundational computing core, which makes them understand where computers can go wrong, and also to get that cybersecurity component, because it's not just the computers that are going wrong, there are the people who are involved there as well. So that's our program that we have out at Cal State. There are other universities who have similar programs starting at both the undergraduate and the graduate level.
And if I'm not mistaken, let's say there's somebody, they start taking courses in high school and they're doing some things, and I mean, they kind of goof around on their own and they're pretty literate as far as computers and things like that. By the time they're a sophomore at CSUB, they could have job offers waiting for them upon graduation.
And we actually have many of our students, even if they're not in the information security program, maybe in another computer science concentration, but they're still taking these electives, and they're going off to jobs in the Bay Area, Silicon Valley, down in Los Angeles, and
they're making a nice living.
Yes, it's one of
upon graduating. And
yes, cybersecurity jobs are one of the top 25 jobs of 2015.
right, and it will probably be one of the top 1 or 2 instead of 25
Yes.
very shortly.
Yes, and that's regardless of which ranking you check, actually, across multiple rankings from multiple large economic analysts.
Everybody wants their stuff safe.
Exactly.
All right, well, you know what? We certainly do appreciate your time, taking some time to come out from CSUB, and continued success with that program, and hopefully Revs Up is available next year.
Yes.
And some high school students that are watching, and kids, if they're not in high school yet, can kind of look forward to something like that to
Yes.
take place out at CSUB, brought to them by Chevron.
Yes.
All right. Proud sponsor of Do the Math as well, which is why we'll throw those guys in there. 636-4357 is the phone number. We have a young student coming up next. Who knows? He might be going into cybersecurity. We'll find out after this. Today we're in San Luis Obispo. We're at Laguna Middle School, home of the Lancers, and today we're here to Today we're at Laguna Middle School. We're in San Luis Obispo, and I've got 7th grader Geneva with us. How are you today?
I'm doing good.
You all right?
Uh-huh.
All right, let's turn around and get ready here. Now, you said you worked a little bit with some pre-algebra stuff.
Yeah.
So that's what we're going to do, because you didn't look like you were quite comfortable with it. So that's why I want to help you through it a little bit, all right?
Okay.
Okay. So when you do get to it later in the year, you'd be like, well, I kind of remember that.
Uh-huh.
All right? So if I had 5 plus something is equal to 12, do you know what would go in there?
Yes,
What?
7.
How do you know?
Because if you subtracted, or 12 minus 7 equals 5.
Okay. And in order to do that, what you could do is you could just take away 5 on this side and 5 on that side, right? You would know that's 7.
Uh-huh.
Okay. So if I had 2x, don't get nervous about anything yet, okay, is equal to 12. Because when we have a number and a variable next to each other, do you know what that means? What operation is going on there? What
that's
is that?
multiplication.
It's multiplication, right?
Uh-huh.
So what are you going to do here? Do you have any idea how we might solve for x? Because we're looking for the value of x.
I know x is 6 because 12 divided by 2 equals 6.
So if we went like this, if we divided each side by 2, 2 divided by 2 is 1.
Yeah.
Right? So on this side we have 1x, right?
Yeah.
And if I have 1x, can I represent that as just x?
Yes.
It's the same value, right? Okay. And then 12 divided by 2 is?
6.
So now what we do is we put that back up into the original problem. Instead of putting an x, we're going to put your value for it, 6. So does 2 times 6 equal 12?
Yes.
So it does, it checks, right? So we know that x is equal to 6.
Mm-hmm.
Okay? So you've got that.
Yeah, I think
Now
so.
let's move on to the good stuff.
Okay.
All right? All right. Give me a single digit number.
2.
And we'll say x, and then we're going to say, give me a 2-digit number.
16.
16. We're not stopping there. Okay? Give me another number, a single digit.
5.
And give me another one.
How about 4?
About 4. This is going to come out to be an unpleasant number. It's not going to come out to be even, it's not be a good number, all right?
Okay.
But we're going to go ahead and we're going to do this, okay?
Uh-huh.
All right. So the first thing you want to do is you want to get things that are the same together, all right? Over here, all we have is a 2x, right? So there's nothing we can do with that,
Uh-huh.
okay? Is there anything over here that we can put together?
We could put 16 and 5 together.
Perfect. And what does that give you?
19. Oh, sorry, 21.
There you go. So why don't you go ahead and put the 21 up there? And what's left on that side?
4x.
Okay. So go ahead and bring down your plus 4x. Now, we were trying to find the value of x.
Mm-hmm.
Okay? So we want all of the x's on one side. Here we have an x, and here we have an x and a number.
Uh-huh.
So if we want to get all of the x's on one side and the numbers on one side, which one is going to have to move?
I think 4x is going to have to move.
Right. And it's a positive 4x, right?
Uh-huh.
So in order to get rid of a positive 4x, you have to do the opposite, the inverse.
Subtract.
Perfect. So you're going to subtract 4x there.
How would I do that?
So right underneath here, you're going to put minus 4x. And over here, you're going to put a minus 4x. Perfect. Okay? Because what you want them to do is you want them to stay balanced and stay equal. Right? So what is 4x minus 4x?
That's just 0.
It zeroes out, right?
Uh-huh.
It's done. Okay, we bring our equal sign down. So what's left on the right-hand side?
21.
Okay, so you can go ahead and bring the 21 down. Okay, and what's 2x minus 4x? So forget about the x's. What's
Okay.
2 minus 4?
That would be in the negatives, I know. Would that be negative 6.
Well,
No,
if they were
negative 2.
perfect,
Yeah.
right? Because if they were both negatives, it would be. So here you have negative 2x is equal to 21. Now, what are we looking for? Just x,
Yeah.
right? Now remember, if we had 5x is equal to 10, we would divide by 5,
Uh-huh.
right? And that would give us x. So whatever's in front of the variable, that's what we divide by,
Okay.
So what's in front of the variable?
2.
2 or negative 2?
Negative 2.
There
Yeah.
you go. So you can't forget the negative sign, all right? So we'll divide each of them by negative 2. So negative 2 divided by negative 2 is?
0.
Well, they
No.
don't cancel out because we're dividing them now. What's 2 divided by 2?
0. Or 1, sorry.
There you go, 1,
Yeah.
right? So it's 1. So now we have our x. Now here's the part you have to do. What's 21? Forget about the negative sign right now,
Okay.
right? 21 divided by 2.
That's around 10.
Right. And what is it exactly, though? You go 21 divided by 2.
Can I solve it?
Go ahead
Okay.
and work it.
So this would be 0.5.
Perfect. And that works out evenly now, right?
Yeah.
Okay. So why don't you go ahead and put your 10.5 right there. Now I have a final question for you. Is x equal to 10.5, or is there something else we need to do to that?
I think there's something else we need to do.
What do we need to do? We need to add something to it, because here I said forget about the negative symbol for now.
Oh, add the negative symbol.
Right. So do me a favor, Geneva. Let's go ahead and read this problem one more time, and then give us the final value for x.
2x equals 16 plus 5 plus 4x, and that equals x equals negative 10.5.
Perfectly done. Nice job.
Thank you.
And just a reminder, we do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. Reason I bring that up is because next week, Tuesday and Wednesday, the 10th and 11th of November, there will be no live programming due to the Veterans Day holiday. So we will have obviously school that week except for Veterans Day, but there will be no phone calls available, live show, anything on next Tuesday or Wednesday. In studio with us right now, we have Avery. How are you?
I'm good.
Why don't you let everybody know what school you go to and what grade you're in?
I go to Ronald Reagan Elementary, and I am in 6th grade.
Now, you're in 6th grade, and one of the highlights of 6th grade is going to Camp Keep. And you guys just went last week. So fresh off your Camp Keep week, tell us a highlight or two of your trip over there.
Well, we went on hikes, and we had about 12 people in our cabin, and we had a lot of fun.
Is that the first time you've kind of gone away like that for a week?
Yes.
Okay, so were you a little nervous about
I was
that
a little
bit?
nervous, but whenever I got there, I was
Did you
fine.
get to go down by the creek and paint your face? And
Yes.
Okay, so I remember that
All
when
that
you
kind
said
of
that you
stuff.
were able to go on that one hike and do the licking of the rocks.
Yeah.
And
Stuck
there's a
your
lot of
tongue and
reasons
everything.
behind all of these things. And for people that have been to Camp Keep, you understand, and those of you that are in a younger grade, anticipate what's going to be coming up. Now, you're here because I wanted you to come in and work on some equations for some students, because we're going to make you a master of doing equations. You may not know that right now, but that's exactly why you're here. So why don't you head on over to the board,
Okay.
and we'll have Chuck write the problem down, and then you are going to go ahead and solve it. And if you get stuck, you've got help right
Okay.
there.
Okay.
Cool.
All right? So let's start, let's go with this one. 20n plus 84 minus 8n is equal to 0. Solve for n.
Okay, so what are you going to do first on that problem?
Well, we'll combine like terms. So these two things, and since this is negative 8n and 20n, we're going to subtract negative 8n. Yeah, we're going to subtract negative 8n from 20n, and we'll get 12n.
Okay,
And
so let's rewrite the equation right below it there.
okay, so
said 12n, right?
Yes, so 12n plus 84. And
And that's
since
going to
these,
still equal 0 because we haven't done
Yes.
anything to the other side. So there's your equation. Okay.
and then
So we want to get n by itself,
okay.
right?
Yes, so we would subtract 84,
Okay.
and since we're doing the same thing on this side, we would do it on this side to maintain the equal sign.
Right. Keep it balanced, right?
Yes.
Good.
Yeah, like a scale. So 84 minus 0 is negative 84.
Right?
Same number. So this stays there, negative 84. And then there's 12n. Now, we want to get the n by itself. So what we're going to do is just divide this by that number 12. And since we're doing it on this side, to maintain the equal sign, we just divide this side by 12 as well.
So let me move it down a little bit, see if we can move it down so we have a little bit more room. Okay.
And so now,
So what happens on the left side?
well, 12 goes into 12 once. So we could write it as 1n,
Mm-hmm.
but really we don't need to. We could just write it as n.
Because 1 times n is just
N.
n. Got it.
So then we keep the equal sign. And 12 goes into 84 7 times because...
Nice and even, right?
Mhm,
Good.
exactly. And since there is a negative sign there, but if you divide a positive and a negative, it'll stay positive. So n is 7, and we
Well,
could
let's see.
check it
If
too.
the signs are different, though, you have a negative and a positive. If the signs are different, what's your answer going to be? When you multiply
Oh
and divide,
yes,
right?
negative 7.
So it's
Okay,
going to be
there we
negative
go.
7. There you go.
And then we could check it here. That'd be negative 84 plus 84, which just cancel out and get 0.
Get 0. And so there's your answer.
All right,
Very
nicely
good.
done.
Very good
Avery,
problem.
well done. Come on over here. I know that I
Good
told you
problem,
that we
good.
were going to make you a master of doing equations. And we're going to get another microphone and a blue shirt for him. And we're just going to go ahead and hire you right now. You good with that?
Good
You
explanation.
know what? We'll get you on the payroll soon here. All right, we're going to go to the phones. Well, let's see. You know what? We'll see. I want you to just listen to the next phone call because I have no idea what it is, and you listen to it as well, and we'll see if we can figure it out before Chuck does. All right? Chanel, how are you today?
Hello.
Nice to see that we've got you back online. What grade are you in?
I'm in 4th grade.
As soon as you're ready, let's hear that math problem.
Okay, so my math problem, it's like, it says, Mrs. Painter's class is taking a field trip to the zoo. The trip will cost $26 for each student. There are 22 students in her class.
So did I hear $26 per student? Is that correct?
Mm-hmm.
And there
And there
are
are 22 students in her class.
22 students in class. Okay. And they want to know what? What's the question?
The question was, what is the full, what's the answer to,
So the
what
field.
would that be when you times it?
Right. So
Right.
I guess the question is going to be, what's the total cost? It's a field trip, right?
Right.
So they're going to I think you said the zoo. So how much is it going to cost total to take all of these students to the zoo? Is that right? All right.
Right.
So there's 2 ways we can do this problem, and we looked at one just a few minutes ago. What I could do is I could take 22 students and $26 for every student. So I could take 26, 26, 26, and I could just add them up 22 times, couldn't I?
Mm-hmm.
But it's much easier. Instead of adding 26 22 times, we're going to take $26 22 times, and instead of add, we're going to multiply, okay?
Okay.
So to get this problem, I'm going to take $26 times 22 students, all right?
Mm-hmm.
So let's go ahead and do that multiplication. So you're doing 2-digit multiplication, right? So Chanel, you're doing 2-digit multiplication, right?
Right.
So let's go ahead and multiply 22 times 26 and see what we get. So what is 2 times 26? Well, 2 times 6 is?
2 times 6 is 12.
So 12, and we carry the 1. And 2 times 2, that's easy, that's 4. And we can't forget the 1 we carried, so what's 2 times 2 plus 1?
2 times 2 plus 1 is 5.
So 2 times 26 is 52. Now, we don't have to do it again because we've already done it once. So I'm going to multiply by 2 again, but I got to be careful because this is actually 20, isn't it? So I got to
Yes.
make sure that I move over one place and multiply by 20 instead of by 2. But 2 times 26 is still 52, isn't it? So if I did it once, I can just write it down again. I've got my 52 and my 52, but I had to add the 0. So let's add it up, and what do we get? 2, 5 plus 2 is 7, and 5 more is 5. So it looks like $26 times 22 students is going to be $572, isn't it?
Okay, so when we get the answer, then they want us to round it
Round it to, does it
to the
say
nearest 100.
to the nearest 100? Okay.
Yes.
So $572 to the nearest 100, it's either going to be 100 or 200 or 300. Well, this is more than 500, isn't it?
Yes.
So it's more than 500, but it's less than 600, isn't it?
Yes.
So the question is, which one is it closer to? Is it closer to 500 or 600?
500.
Well, let's see. 550 would be right in the middle, wouldn't it?
Mhm.
And this is more than 550, isn't it?
Yes.
So it looks like our answer is going to be $600.
Oh, okay.
Okay, we're just going to round up to 600. Okay? All right.
There
Thanks.
you go.
Thanks for the
Nicely
call.
done, Chanel. If you do have some more problems like that, we do have phone tutors available until 5:30. Right now, I know we were going to have you do an equation, but we're going to have you work with a triangle right now.
Okay.
All
Okay.
right. So Chuck is going to go over. This is actually something that you guys were reviewing in class,
Yes.
and we're going to go ahead and have Avery do this, which will kind of be a review for him as well.
We did some triangle problems yesterday on the show with sides, and so we were looking at triangle problems with angles. And we said in this triangle, and sometimes we'll label it like triangle ABC, if you know two of the angles, like this angle is 65 degrees, and this angle is, say, 56 degrees, can you find the third angle? So how do you think you're going to do that
can.
problem?
So first, we know that there are 180 degrees in a triangle.
Mm-hmm.
So if there is 56 and 65 degrees, we could just add that up.
And that tells us how many degrees we have already, right?
Yes, exactly.
Okay.
So 56 and 65. Now, 6 plus 5 is 11, carry the 1. And then 11 again, carry and add the 1 to that. That's 121 degrees. So if there's 121 degrees, we just want to find out, since there are only 3 angles, this is the last angle, we would subtract 121 from 121 degrees from 180 degrees. And we would get what that angle is. So 1 can't subtract from 0, so we'll do that. And then 1 minus 10 is 9, 2 minus 7 is 5, and 1 and 1 cancel out, which is 0. So this angle C is 59 degrees.
So you're saying that 59 plus 56 plus 65 should give us the 180.
Yes.
So you did two things. You figured out first how many degrees we had,
Yes.
121, and then you figured out how many more degrees we needed to get to 180,
180.
which was the goal, 180 degrees.
All right, nicely
Perfect.
done.
Good
Good
problem.
work. Come on back over here. Now, when Chanel phoned in, I had you kind of think, you knew how to solve that problem as well, right?
Yes.
So you're on a roll. All right. 636-4357 is the phone number. We do go to our next phone caller, and I believe this is a student from Fresno Pacific, correct?
Yes.
And what's your first name?
Jennifer.
All right, Jennifer, why don't you go ahead and tell us the math problem that you're working on?
Okay, so it says here's a simple exercise on actually doing the mathematics on how an earthquake is located. So it says, let's let the P, or primary wave, be represented by a bicycle moving at 16 miles per hour.
Okay.
Let's let the S, or secondary wave, be represented by a walker who walks at 4 miles per hour.
So
They
this
both
sounds,
got
this
four.
sounds like a really difficult problem that we're simplifying using the bicycle and the walker. Is that right?
Yes.
So we don't need to know anything about the primary wave, and let's just do the bicycle and the walker problem? Good.
Yeah.
Okay, that sounds good.
Okay, so it just says, what is the distance from the starting point to the recording station, and how long has the bicycle been on the road, and how long has the walker been on the road?
Okay, so we have a starting point, and we have a recording station. So starting point, and I'll say starting point is starting point, and this is the recording. Okay.
Yes.
All right, so what do we know?
Okay, so all we know, it says they start in downtown Fresno in front of the courthouse building, and as soon as it says the recording station some distance out of town records the time to arrive, and finds out the bicycle arrived 1 hour earlier than the walker.
Okay, so we have a bicycle, and we have a walker. Is that right?
Yes. Mm-hmm.
Okay, and the bicyclist is, you said 1 hour less? Is that
1
what you
hour
said?
earlier. Yeah, 1
1
hour
hour
less than
earlier.
the walker.
1 hour earlier. Okay.
Yeah.
And what else do we know?
And it just says a recording station some distance out of the time record. The time the two arrive and finds out the bicycle arrived 1 hour earlier than the walker. That's all it says.
Do we know anything? So we're talking about distance and we're talking about time. How about the rate? Do we know how fast they're going?
Yeah, we do. The 16 and the 4 miles per hour.
Okay, 16 miles per hour and 4, so 16 must be the bicycle, right?
Mm-hmm.
And 4 miles per hour for the walker?
walk.
Okay,
Mhm.
so we have a formula. We know that distance equals rate times time. So
Yeah.
we know the rates. We know one rate is 16, that's the speed, and one is 4. The distance is the same, isn't it? The distance
Yes.
is from the starting point in Fresno to the recording station, okay?
Yes.
We don't know what the time is, right?
No.
But we do know that the bicycle is 1 less than the walker. So if I let this time be t, then what's the time for the bicycle?
The time for the bicycle, wouldn't it be 4?
It would be an hour less, wouldn't it? And I don't know what
Oh,
t
1
is.
hour. Yeah, 1 hour less.
So it's
sorry.
going to be t minus 1, isn't it? So t for the walker and t minus 1 for the bicycle, okay? So let's figure out the distance that each of these things traveled. So here's the bicycle. The bicycle is going to go distance equals rate, which we said was 16 miles per hour, correct? Times the time, which we don't know, but we said it's t minus 1,
Yes.
where t is the number of hours the walker did. So now we have the walker here, and this distance is, well, rate times time, which is going to be 4 miles per hour, times their time, which we said was t.
6. Yeah.
All right? Okay, and the thing that sets up our equation in this problem is that the distance they travel has got to be the same.
Okay.
So let's set them equal to each other.
Okay.
So I'm going to set 16 times t minus 1 is going to
Okay.
equal 4t. How's that?
Okay. 40. Okay.
All right, so I have the distance of bicycle traveled and the distance of walker traveled, and we're going to use the distributive property to get rid of the parentheses. What do I get? 16t minus
T
6t
minus 16.
equals 4t. Let's see. Let's subtract 4t from both sides.
Okay.
That'll give us 12t, is that right?
Yes. 12
And
minus 16.
add 16 to both sides, so 12t equals 16. Let me see if I can move this down.
12 equals 16.
And so
Okay.
it looks like our time is going to be 16 twelfths, which is going to reduce, right? By what? By 4?
By
So that'll
4,
be
yeah.
4/3. So it looks like the time is going to be 4/3 hours. Or
Okay.
1 and 1/3. How's that? 1 and 1/3 hours.
Yes.
All right, now we got what t is, but did we answer your question?
No.
What's the question?
So it just says that's the one. So basically,
would I use how long the bicycle has been on the road? Would I use the same, would I use the same equations to figure the same thing out?
So the walker has been on the road for an hour and a third, 1 1/3. So what's the time for the bicyclist?
So then would I set up a different equation?
No, it's just t minus 1.
Oh, so T minus 1.
So it's 1 1/3 minus 1, so that's going to be 1/3 of an hour.
So they would both be 1 1/3 an hour?
No, the walker took an hour and a third to travel that distance.
Okay.
But the bicycle went the same distance in only a third of an hour.
Okay.
Because you're going 4 times faster, isn't it?
Okay.
Okay, so that's the time. What was the other question?
And then the other one is just, what is the distance from the starting point to the recording station?
Okay, so distance equals rate times time. So what do you want to use? I'd like to use the 1/3. How about 4 times 1/3, right?
Yeah.
Isn't it 4 miles per hour times a third of an hour? So it looks like the distance is going to be 4/3 miles. How's that?
Okay, 4/3 of a mile. Okay.
Does that work?
Got it. Yes.
Okay, I'm sorry. T was, yeah. So T was 1 1/3. So it's 4 times 1 1/3 for the bicyclist. So that's going to be 16/3 miles, isn't it?
Well, it'd be 5 1/3 miles.
So that's going to be 5 1/3 miles. I'm sorry, it's going to be 4 times 4/3, right?
So the bicycle would be it would have been on the road for 1/3 of an hour?
The bicycle for 1/3 of an hour, the walker for 1 1/3 hours. Because it would be 16 times a third, that's going to be 16/3.
Okay, and then the distance would be 4 1/3, you said?
No, it's going to be 16/3. It's going to be 5 1/3.
Oh,
5 1/3 miles. It's going to be
5. Okay, I see what you're doing.
Got it? 16/3 miles. How's that? Got it?
Yeah. Yes.
Think we did it. Okay, thank you.
There you go.
Right, thank
Nicely
you.
done. If you do need some more help, we do have phone tutors available until 5:30. Well, young man, you're not old enough to work on the program yet with the button-down blue shirt, but we're going to make you our newest ambassador with a blue shirt, t-shirt style. So what that means is you're going to be our newest ambassador. You know what that entails?
I do not.
It means you are going to have to tell some other people about Do the Math.
Okay.
You can do that for us?
Sure.
All right, nicely done. You know what? Every day when people phone in, we do their math problem on air. Everybody has an opportunity to win themselves a 4-pack to go see the Bakersfield Condors. And right now, how much time do we have, John? We're in our final minute, right? So why don't you go ahead and we'll find out who's going to see the Condors.
Jennifer.
Jennifer from Fresno Pacific, the young lady that just phoned in right now with that great problem. So congratulations, Jennifer's going to see the Condors. Have you been to a Condors game yet?
I have.
You have?
Yes.
They're a lot of fun, aren't they?
Yeah.
Well, you know what? If you call in sometime, because now you know how the show exactly works because you've been on it. Sometime you can call in and you go, hey, this is Avery. Remember I was on there? Well, yeah, let's go. You better have a nice problem to work on. And then your name will be in there Sunday, and who knows? You might be going to see the Condors as well. Okay. Anybody you want to say hello to before we take off?
I would like to say hello to Akil Gorla and David Bonilla.
All right, well, there you go. Hopefully they're watching, and I'm surprised they didn't call in to make you do a hard problem. Yeah. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, Panama-Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.